There's a lot of stuff going on this smart cities and smart utilities and smart infrastructure. And what I want to do and the way we are going to go through it is we're going to basically dissect it little by little. And I thought we would begin with connectivity because everything needs to be connected. So let's talk about what that means. So there's a bunch of trends going on in the industry. So you heard about 5G, you heard about IoT and Internet of Things, and there's all these other acronyms and things, so issues. So there's licensed spectrum, unlicensed spectrum, there's narrowband, there's broadband, there's wire stuff, there's wireless stuff, you got fiber, you got, all bunch of what I would call wire standards, the latest one, which is one of the 34th books that we just wrote and published, IEC 61850, and there's all kinds of things going on there in terms of how we communicate in this infrastructure using wired technology, if you will. And then there is an even greater number of challenges and opportunities around the wireless side, things like RF mesh and LoRa and LWPA and Wi-Fi and you name it. There's another 32 that I'm not mentioning. So I want these guys to kind of walk us through, first of all, who they are, what they do, what their companies do, maybe take 2 or 3 minutes. And then let's start peeling the onion about the use cases, why so many technologies, how does it all come together, why does it matter? So let's start with Pete. Use the mic.
I'll use the mic. Okay, can you hear me? Well, good morning. Andres, thanks for allowing Tantalus to participate. It's a pleasure to be here today. Tantalus Systems is a 30-year-old business that has focused on delivering AMI and smart grid solutions, particularly to the municipal and electric co-op market segment across North America, including Canada, the US, and the Caribbean region. Today we support 160 utilities. In the aggregate, that represents about 2.5 million meters that we've deployed. We manufacture the communications module. We're the first organization to distribute a communications or deliver a communications module with a Linux-based distributed computing platform back in 2013. We partner with groups like Itron and a few of the other largest meter manufacturing companies in the world to deliver a comprehensive metering solution for the utility. And based on the granular data we can extract from that meter, we then integrate other devices like load control, distribution automation, street lighting infrastructure to help the municipal and electric co-op provide reliable services across their footprint. Thank you.
Good morning, Steve Lowe with AT&T. I think everybody knows who AT&T is, but I want to tell you a little bit about the group I'm within. I've been with AT&T for about 20 years. Before that, I was with American Electric Power, and I always like to throw that out. I feel like I'm still a utility guy. Enjoyed my time there on the distribution side of the business, but within AT&T, I work inside of our IoT team that's led by Chris Penrose. I like to think that I work for a startup company. It's a startup company inside of AT&T, so it's the best of both worlds. We have the funding of a large corporation, but we have the flexibility to be able to do some innovative things. That's kind of an oxymoron sometimes when you talk about utilities and you talk about AT&T as being innovative and quick moving. But what we've been able to learn is that we're taking the foundation of an AT&T company and being able to start to meet those needs. I really appreciated Mr. Dickerson's comments about where we want to end up. And so I work underneath the Smart Cities group. And in Smart Cities, what we're trying to do is try to understand what cities are trying to accomplish. And the first discussion we have with them is around enablement and what they're trying to enable for their constituents. And then we go from there and we work back. AT&T and the group I have and lead the sales team for, we have about 8 different products and sets of applications that help to meet those needs for citizens. So appreciate the opportunity to get to speak with you today.
Thank you, Steve. Go ahead, keep that mic on that side. Mike?
Thanks, Andres. So I'm Mike Robinson with Cisco. Cisco Systems has been in the utility business for a long time. A lot of people may not know that. Interesting tidbit of information. We have approximately 10 million meters in operation using Cisco Systems software and equipment technology. I particularly am in a group that focuses on electric utilities. We also have smart cities and a whole cadre of IoT initiatives within the company. I particularly have been helping utilities predominantly on the western side of the United States, with kind of an emphasis on Hawaii and California, particularly where renewables is really impacting grid operations and this sort of a thing. From a technology perspective, our wireless technology that we predominantly use in the field area network would either use cellular technology, 4G type technologies, the RF mesh. And we're really excited about the new Wi-Sun standard. We think that that's going to be a big game changer. And then LoRAWAN.
Mm-hmm.
Hello, I'm Jeff McElroy, and as Andres mentioned, I've known him, I think, since 2012. I was having that conversation before. I was with the General Electric Industrial Communications business as the product line leader for a period of time and the global sales leader. And about 2 years ago, I came to this company out of New Zealand called Tait Communications. And Tait Communications historically has been a hardware provider providing mission-critical voice systems and LMR. When I came over, I was really interested in some of the things they were doing, particularly around the area of connected vehicles, which we call the unified vehicle, and also with telemetry over LMR. With the connected vehicles, the initial vision was the combination of multiple bearers. The LMR industry has a lot of challenges. Talking with Steve, saying is AT&T a competitor? But for us, we view the LTE and 5G as a grand opportunity because LMR systems will still remain in place simply because of the safety aspect and the coverage. So the challenge for our customers, how do you integrate and use both of the systems at the same time? So the first attempt at that, which we launched globally, is a combination device in the car that connects LMR and LTE seamlessly so a utility can leverage both networks at the same time in an optimal way. Since I've got there, we've taken that a step further, or at least I think we're taking a step in the right direction, of the vehicle becoming a data acquisition device. If you look inside the vehicle, there's lots of data that can be valuable to the customer, the utility, safety for the employees, safety for the community, location services data from the vehicle fleet diagnostics, codes, environmental sensors, the ability to collect video and use that for further analysis. And through that process, if the industrial communications business, I guess my area of expertise would be in data for utilities, is now that we've seen some of the shift from these existing LMR networks move for a significant load to be moved to LTE, additional capacity has been made available to use those systems for data acquisition, for closure controllers, capacitor enclosures, communications with RTUs. And our team in New Zealand developed a very unique way to handle the traffic between our regular channels and the control channels to optimize the use of data. So we're furthering both of those products together, which were started in a siloed manner. As I really like the comments about the culture that Lisa mentioned earlier, because internally that's a challenge for our organizations as well as the customers, is bringing those two platforms together into one platform so you could have the combination of what we would call a unified critical communications platform as well as an IoT platform, which helps solve multiple problems and allows, as I like to say, the applications utilities already have work better.
Good morning, everybody. Ty Roberts, met many of you last night. I'm still the VP of Marketing at Itron even after last night, for our global network solutions. A couple of things I want to touch on that Itron is focused on, because we think this is important for the industry, is a lot of our investment over the last 5 years in our AMI platform, which Charles was pointing out earlier from Austin Energy's perspective, has been on building devices that are capable of running applications at the edge. Because one of the things that we realized in working with, in particular on the Governors Association, probably as an industry representative within that organization, several years ago, looking at the evolution of the electric industry, in particular, the distribution part of that, and how indeed, as Charles described, with the increase of distributed production, distributed generation, that the low voltage part of the grid is truly becoming a dynamic two-way network. And also, as Charles noted, it was designed to be one way. So having this concept of centralized control which is the basis for the grid, the grid's reason for being and its design fundamentally does not fit that future paradigm. So pushing the ability to make decisions and take action at the edge is a must-have in an environment where it is two-way flow of electrons. So that's been a clear focus of ours. And the other is really, I think, related to this pastiche of stuff that you see up here. I feel incredibly sorry for our customers, for utilities who I know have people coming to talk to them every week about one of these things and how wonderful it is and how great it all is, and it's going to solve all their problems. When at Itron, we've done a lot of work, obviously, investing in RF technology and deployed a lot of RF technology, but we've deployed a lot of cellular technology as well. In other parts of the world, we've done a lot of work with LoRAWAN and Sigfox-based solutions, other technologies, PLC, for example. One of the things that we really believe is that different communication technologies solve different problems. Let's take that away from, let's take that out of our customers' heads. That shouldn't be something that they worry about. The how is something they should not be worrying about. It's what do they want to accomplish. And our belief is that we need to, as solution providers for utilities and for cities, we should be bringing a toolkit that solves their problems with the right service level agreements and the right economics. And how we do it, so long as it's standards-based and viable going forward in the future, and we're able to stand up for its longevity, then it's a good solution. So trying to take this complexity, this spaghetti of how off of their plates and out of their heads, and talking about what they want to accomplish is how we're really trying to pivot the conversation.
Excellent, excellent. All right, so now you know what they do a little bit, right? They're wonderful human beings. You should see them play golf or go fishing or hunting. That's usually what I like to do with them. But here's the thing. So everything needs to be connected, right? And Charles said something that is right on the money, right? A smart city, a smart state, a smart nation cannot happen if the building blocks of that, the power utility, the water utility, the telecom, and the IT is not smart. So in order to get to that panacea, we need to figure out how we get the utility smart. Now, Austin Energy is clearly pretty smart. I'm a little biased about it. You could read all about it in Chapter 4. And Dan and Charles and company are taking this to the next level, which is exciting to me. But why don't we talk about, I want you to really, and it's okay if you get into Jerry Springer. I'll stop you guys from hitting each other. But so we got people communication, you got crews on the field doing things, right? You got customer communications, you got the devices. We're going from a few 100,000 things to billions of things connected. And how do we get the utility smart? What's going to happen? How do you peel the onion? So you talked about some of the use cases. So that's what I want to get into. Tell us what's happening, who is doing what, and why is that important about how do we begin automating the utility, the generation side, the distribution transmission side, the customer side of things. What's happening, right? So I'm throwing this big question to answer because these guys can talk about this for hours. So I want you to start at the beginning again and say, Pete, why is this happening? Why is it important? What does Tantalus do? What are you seeing? Give me one or two customers that are doing something that basically exemplifies what we're discussing here. What are they doing with it? Why are they doing it? How are you helping them?
So thanks for picking on the little company up here. In listening to my colleagues to the right, I'm realizing I'm out of my league. So let me give you a few examples of the organizations we help. And I'll give you two extremes in focusing again on the municipality and electric co-op utilities. We've already learned that Austin Energy is the third largest muni in the country. The smallest utility we support has under 1,000 meters. To give you some perspective on the differences of an organization like Austin Energy to small town USA. And in between, we support utilities big and small within this market segment. So a couple case studies on what we've seen. One of our larger utilities that we support is EPB Chattanooga. It is a decent-sized municipality at about 125,000 meters. They were I think, among the first, if not the first, utility to go down the path of a fiber to the home solution to compete directly head-to-head with the cable providers, which their community felt was under-servicing Chattanooga, as well as trying to drive substantial automation across their city and improve services to attract business, to regentrify and drive economic development for the city. Our technology is the basis for their fiber to the home solution, and something that we're very proud of, given the fact that we're a relatively small, innovative organization. When you walk into their utility, it is among the most sophisticated command centers in the country in terms of what they are able to do. And we talked and we heard about Austin Energy grabbing the interrogation of meters on a minute-by-minute basis. EPB is doing that on a sub-second basis in many circumstances. And the reason why they're doing that is they are trying to drive safety, reliability, and improved customer service. Those are their three drivers. That's one case study and an extreme example of a utility not only enhancing what they do day to day, but also launching into a new service offering and revenue model in terms of bringing triple play to their customers. And today, EPB represents about 50% of the market in Chattanooga for broadband, TV, and phone, above and beyond what they do in terms of keeping the lights on and delivering electricity. Pretty fascinating case study for us. The inverse is we deal with utilities who fundamentally, and I think to Tai's comments, don't care about the how. They have homes and farms outside of a major metropolitan area dealing with challenging terrain. And their goal is not focused on broadband capability, but delivering shared services and equivalent services to either their members or the constituents inside a municipality, particularly in a rural footprint. And the challenge there, as you think about some of the buzzwords and the technology that's on the screen in front of you, is some of these things get very challenging in very rural and treacherous terrain environments. The utility's goal, singular, provide the same services to all of their customers regardless of where that person is. And so in that circumstance, it's a lot less about broadband. It's utilizing different types of RF technology or communications technology in order to ensure that there is an automation of the meter to provide that customer with actionable insight, as well as ultimately helping the utility offset the operational cost of supporting a home, a farm, a business that could be legitimately a 4-hour ride from their main service center, consuming almost an entire day for a service truck if something's wrong. So those are two extremes of what we do, and as a result of that, I think to Tai's comments, what we focus on more so is what the right technology is relative to the circumstances of the utility, as opposed to potentially what's the best technology relative to the future vision of major metropolitan areas.
Sure. So when I look at this slide, I hear it really resonates with me, something I hear from utilities across the U.S. I have the opportunity to be able to travel and meet with investor-owned utilities, cooperatives, and municipalities. But what I hear is the term purpose-built networks. And when I hear purpose-built networks, I think about the fact that it sounds really good until you look at one utility in the Midwest told me they had 18 purpose-built networks. So then when you look at this, you look at all these different technologies, something that AT&T is trying to do is help to reduce the complexity of the infrastructure. Okay? Of the infrastructure required to be able to support that. So again, what we're trying to do, again, going back to Charles's presentation is that look at really what you're trying to accomplish. And then trying to make sure you have the right infrastructure in place to be able to meet all those needs for what you're trying to accomplish, but also being able to meet those future needs. There's no way that we can future-proof a network, but we can do the best we can to make sure the investment you're making today will support everything you need today. And so we're trying to reduce those 18 networks to 4 or 5 networks. We know that you can't get it down to 1 network, but we can definitely reduce it. So maybe we can reduce all those words on that slide chart down maybe to 3 or 4 words, and which would make life a lot easier. And then the reason that they want to do that is the fact that in investor-owned utility world, capital expense is king. Operational expense is, the criminal. And so they're trying to reduce those operational expenses. In 2015, the thing that I have really a passion for is AT&T took on the initiative to try to provide spectrum to the utilities for them to be able to use for their own use in a private world. So we've designated a portion of our spectrum for utilities. It's about 10 megahertz of bandwidth, which should meet immediate needs and future needs. We're working with our key partners with providing the hardware, software, and services to support it. So what it does is allow them to leverage what global communication companies are deploying today using LTE technology. Has the 4G capability, the 5G capability, and then we would be able to allow them to build their own network. In some situations that makes sense, investor-owned utilities with municipalities and cooperatives, it might make more sense for us to provide it to them through a managed service. But really our focus is trying to reduce complexity, allowing utilities to have more control of their reliability, more control of their resiliency and latencies, and do it in a way that is much easier to manage. So definitely private LTE is a future. That's an overused term. You know, I'm kind of equating it now to smart grid. Everybody has a different definition of smart grid. Soon everybody's going to have a different definition of private LTE. We look forward to chatting with you later about what private LTE means for you with AT&T.
Yeah, so historically, for the last several years, Cisco's been helping utilities from what I would characterize the wide area network. And most utilities have private infrastructure in combination with the use of services from service providers, but that segment of the network between like the control center and the substation is going through a rebuild so that you can bring on and host additional services. I'll just kind of like say one quick thing about that. One of the things that really irritates me is when those infrastructures get built and they look like a packetized version of the past. That's simply not going to be the right kind of technology that's going to help going forward. But I guess to kind of turn the page here, what is before us is the build out of infrastructure that goes from the substation out to the homes and the businesses and this sort of a thing, the field area network. Cisco has been working with a lot of utilities to help work through those issues and come up with solutions for that. And we're very excited about the WISUN technology. In addition to cellular, cellular is a huge piece of our play for utility operations. But we do see a lot of opportunity in WISUN. One utility in particular that I'll mention is Hawaii Electric, who has a very audacious goal of being 100% renewable in a very short time period. They're presently approximately 45% renewable right now. They're at the throes of building their field area network. The challenge that they have, though, is that instead of across-the-board application of technology and metering and what have you, they have an opt-in program, which it really introduces complexity. The reason why is because you're not going to get density at the early ages, which is important for a communications person to think about how this technology is going to flow. So as a result, we kind of have to think outside the box and integrate a combination of technologies instead of have one technology kind of be the master technology. It really, really is going to have to be an integration of multiple of these.
Thank you. Yeah, the interesting challenge with Tait being an LMR provider is if you look at the utilities' perspective, is their focus is primarily what's on this screen right here. So we have customers who need to have upgrades. They wanted to do upgrades, but many of the opportunities would be stuck. And so through the process, we'd say, well, what else can we do with this network? Because your point about the purpose-built networks, LMR is a purpose-built network in many cases. And so the strategy that we deployed is, we need to focus on upgrading our customers, obviously. There's customers who haven't upgraded their networks. They know they need to, but what often happened is in the budgeting process, they would come through and say, well, there's all these other priorities. This one isn't quite as important as what you see up on this screen. So the idea is get them to focus on what else can we get the network to do. And that was a big challenge because they said, well, let's talk about data. They said, well, this is how we do SCADA now. Can you do it exactly the way we're doing it, but use it on your network? And the answer is usually no, it's because the technology is different. And then you look at workforce management or dispatch. And they said, well, could you do this exactly how we're doing it now? And the answer is generally no, you can't do that. And so through a process, which I think is a cultural shift, is leading some workshops with customers globally using the outcome-driven innovation framework, is to get the customers to really focus on the desired improvements, which gets to the point that you made, is rather than focusing on how you do it, is what outcomes can you get for the customer. So usually what we're starting with is we need to increase the amount of time our employees are within coverage of any type of communication barrier, whether it be LTE or whether it be LMR. In the case of data, it's like, we need to have an increased number of RTUs that are under management, that we have visibility to. And many of our customers, particularly globally, have locations where there isn't cellular coverage. This is, the jungles of Brazil, Colombia, Chile, Peru, Spain. We have about 20,000 points in place for data, which was interesting because it started as a data network on LMR, and now it's becoming a voice network. And I'll talk a little bit about how we did this, because we first started, they said, this is what we'd like to do. This is how we like to interrogate our data devices. And we run the numbers, it won't work. So we said, well, this is how we suggest that you run the data, and then it works fine. But what does the distribution engineer do? He just polls exactly how he polled it in the past. The system gets up to max capacity, and then there's a problem. So you get into looking at new ways to interrogate the data, but still give the fidelity and quality over LMR. Because if you look at most of these networks, 65–70% of the time, the status report that comes back is everything's exactly the same. And then you're still using your legacy protocols. And so you're having, actually, what is lightweight, still relatively heavyweight, is developing some logic to thin that data, potentially change the protocols, and make that data traffic not as large of an impact, so you could actually use the system for voice and data. And with this strategy, which I think is still in its infancy and can be improved greatly, we have deployments in about 14 countries with this technology. And sadly enough, and one of the reasons why I'm here is most of them are not in the United States. And we'd like to improve that. But it's a dramatic impact for utilities where spectrum is limited. The cost of building data spectrum, whether it be licensed narrowband or LTE, isn't quite, doesn't pencil out today. But that's one way we're really having an impact for our customers globally, is giving them the ability to acquire data over infrastructure that they already have, using spectrum that they already have. I'll just kind of leave on that.
Yeah.
Thanks. There's two trends that I wanted to talk a little bit about. So Itron, working with Cisco starting in 2010, and about the same time, Silver Spring Networks, whom Itron recently acquired, had the same vision of building a multi-service network infrastructure for utilities, so that if we're trying to go from, as has been said a few times, from multiple point solutions into a foundation or an infrastructure that can be used for multiple things. One of the most exciting, very recent uses of that we're starting to see, and I say starting because it really is in its infancy, and this goes back to, I think, why it hasn't happened earlier is largely regulatory in nature, is large IOUs have the capital, have the people, have the sort of the IT acumen and a lot of the supporting infrastructure to deploy AMI networks and manage and maintain them on their own. And there's some of the larger municipals have the same, but smaller entities simply don't. And this is where Pete's talked about, Tantalus is really focusing on smaller market, which is fantastic, because I think there's a risk that those entities, smaller municipalities, get left behind. Where we see there's still challenges, especially is in gas and water in particular, where there's no money to spend on smart infrastructure and digital infrastructure with small municipalities. And there's a sense that, hey, what about us? We're getting left behind, and the citizens of those entities feel shortchanged. So one of the interesting things that we've seen starting in California, as many things that are new and interesting and innovative do in this space, for whatever reason, is there was a California PUC mandate to have to allow shared infrastructure and shared use between electric utilities and water utilities in particular. that we're really starting to see become a viable sort of method for collaboration around the country is water utilities and municipalities wanting to digitize, wanting to take advantage of smart infrastructure for their customers, their water customers, using the infrastructure of the electric utility that's probably already deployed a communication infrastructure and a smart metering infrastructure that they may have done for electric and or gas metering to begin with, but using that same multi-service infrastructure to provide service to the municipality, which is fantastic because this is the expertise and the capability it takes to run these networks. It's not trivial. A lot of large utilities, investor-owned utilities, have, it's essentially similar to running a modest-sized telecom network in-house. So this is a capability and a technology that they're able to leverage for sort of the have-nots, if you will, that are in their service territory, which I think is a fantastic development. So we're seeing that multi-service network be used to provide services from the folks who've already spent the capital to deploy them to provide services to those who just don't have the financial and person power expertise to do that. That's an amazing trend that's starting. And the other facet that I mentioned a little bit earlier so Itron's investment over the last several years on the electric side has been on this distributed intelligence concept, where what we saw in the business cases that we'd penciled out that really drove a justification of pushing computing power from entirely being back office to being distributed across back office, but also to the end devices themselves, where analysis can be taken at both ends of that spectrum, action can be taken at both ends of that spectrum. There's a degree of autonomy that devices in the field can detect conditions and take action in the field in order to solve problems that you could not do only in the back office. A lot of the justification around that and the financial justification around building that capability was on sort of grid optimization and preventing overloading of transformer assets, for example, or always knowing where every meter is electrically on the network, what feeder, what transformer, what phase it's on. All of these are incredibly hard problems that utilities can't solve any other way today. What we're seeing, however, is that's very interesting to a lot of our customers, but what's more interesting to several of them, very recently especially, is the use of that capability of running applications and having computing power on the side of people's homes is providing services into the home to the consumer. So I don't want to give away special sauce of some of the customers that we've been working with, but a lot of these are sort of based around being able to look at characteristics of load in the home to know that the kids have come home and notifying people that your kids are now home because I can see that stuff is starting to run, or your elderly parents are up and awake and I see that they've turned on the coffee pot like they usually do, so good for you. These are all opt-in services, by the way, not to give the sense that this is your creepy uncle state watching all of this happening. And then also the ability to provide actual monetizing services to utilities, or to customers rather, from the utility. So appliance health, for example, being able to proactively monitor that on behalf of the consumer. So that concept of distributed capability, really where we see utilities, the forward-thinking ones especially, starting to apply that is providing home services, which is a really interesting development from our perspective.
All right. So we got 2 microphones. I need the questions on the recording because I'm trying to capture. We're writing white 9 papers. We want the folks writing be able to go back and listen and what was it say? What was that word? So if you are too far, I want to know who has questions. Raise your hand. If you're too far from the mic, I'll take the liberty of repeating your question if you shout it. But do we have any questions for this gentleman? And while you're formulating that question, quick question. So there's a lot of myths out there. We don't have enough standards. There is not enough interoperability. Blah blah blah. We're not ready. We need to wait another 10 years. This is my answer. We have all the technology. It's all baked. It's all ready to go. It works. I want a confirmation from the experts on the panel on my assessment. Yes or no on what I just said. Yes or no. Is it ready? We're ready. Prime time. Oh my God. The CEO just told me it depends. You're not in front of the board of directors, man. Come on. It depends. Oh my God.
I'm just going to say yes, it's ready. Come on.
It is ready. Come on, guys. All right, any questions? Yes.
Zidang Zong from the Computer Science Department of Texas State University. I want to ask a question on behalf of the researchers, right? So most from the industries, right? So Texas State University is building a research center that aims to conduct research in industry-relevant problems, right? Challenges we want to address with the industry together, and which is good for our students as well for their career service, something like that. Our faculty and researchers usually got confused, like how to start a collaboration with the industry, right? So you have the data, domain experts or something like that, and we may have experts in algorithm or something like that, but we need to learn what is the best collaboration model, how to get the collaboration going. Could you address that? Thank you.
We partner with several universities, so I can give you some guidance as to what we do, and more than happy to give you some perspective on that as you think through initiatives for Texas State. The data that we are capturing at Tantalus, because of our Linux-based computing platform that's been in the field for almost 6 years, if not close to 7, and that concept of edge computing, almost autonomous capability, it is providing utilities, our customers, with a volume of data that is, in some circumstances, overwhelming. Example, we have a utility in South Florida that's in the lightning capital of the world. They don't have proper grounding, not sure why they need to make that investment, and we capture sags and swell alarms, right? Changes in voltage, more often not indicating a fault, and in conjunction with that, tied to transients. What does that mean for them? The server that we put in place for them to capture those sags and swell alarms, and this is an anomaly, an extreme case, they are the first and only utility of 160 to actually exceed the data limits of what we originally designed. That shows us a real problem. Where we think about partnering with university is how do we, in capturing that data, how do we run some statistical analysis, the statistical modeling around that to drive analytics, right, to help that utility pinpoint what's driving those transients, where specifically those faults are, and how they ultimately improve reliability. Most of our engineering expertise is around communications, the efficient use of spectrum, the delivery of data. We don't have a lot of data analytics capability. We don't have statistical mathematicians that are running those models in the background. That's an opportunity for us to partner with universities, and what we've already done up in British Columbia, so that we can think through a variety of different analytics that become actionable data and knowledge for the utilities. So that's an opportunity.
So
Will 5G be more expensive than 4G?
I don't know that I can answer that. I mean, 5G brings a lot of new technology that's being driven by the applications that require it. The faster latencies, the more concentrated areas of higher density populations. As far as what we're going to do from a cost perspective for an expense, I probably can't address that. Probably will get fired for addressing that. I guess the right answer would be it'll be worth every penny you pay for it.
I'll also add that 5G is going to bring some phenomenal capabilities that weren't available in previous generations. And one of the things that it's going to do is it's going to allow entities like enterprises to make their own private investments in 5G in collaboration with what the service providers will do. So this is one of the things that this concept of private LTE is going to come out in numerous flavors. The perspective of private LTE that we've seen in the past is only a glimmer of what we're about to see in the future. But to answer your question, it's not just the service providers investing in this. We're going to see enterprises investing in 5G.
What needs to change in the system for this to be really ready for prime time? Because it's going to be broader than just the communications that we discussed to start off with.
So I can real quickly talk about it because I said depends. The reason I said depends is the fact that the infrastructure is there, but again, to answer Lisa's question, every device has to be compatible with the current technology. And so the roadmap for those are somewhat extended. They're probably out 18 months, 24 months, 36 months, and until those are there, the technology is not available.
I'll just add real quickly that My it depends is the evolution of how information is used. And I'll just point out one thing, that we have these silos of information. Some of the things that actually Itron's doing with being able to look out at what's going on at the meter and getting more than just utilization data, but sharing that data across multiple systems, those are going to be the things that will accelerate the implementation of newer technology. So it depends on the utilities' adoption of thinking outside the box.
Do you want to add anything to that? Okay, no, good. You want to add something?
I want to add, the reason why I said yes is because I believe all of the required components are already out there, but all the required components generally don't sit within one organization. So if I were talking to a utility customer in their plan, there's a high probability that everybody on this panel would have a piece of that solution. And so the interoperability is the integration on the back end. That was one part I missed that in my talk earlier, is our customers, we really found a sweet spot is the integration of this data. These purpose-built networks often provide data without the context or the semantic data, as well as proprietary interfaces, so the integration can't take place between the entities. So one of the things we're doing is taking this data, adding the semantic context, and putting it in a usable form and accessible via APIs, which we believe fits the strategy of the next generation of IT, as well as the way enterprise applications expect to operate. So every data becomes usable immediately and at a future time, and it allows for quick implementation of applications that have value.
Help me thank the panel for their time.